like I said, we are looking at 3-2, day 2. Today we are focusing on something called the elimination method. So go ahead and please complete the 4 warm-up problems at the top of that page. So go ahead and complete the 4 warm-up problems at the top of that page. Bless you. Let's go over those answers. So in example number 1, you had to solve for y. X was already solved for you. You got x equals 4. So our solution to that system by substitution was 4, 9. Number 2, you solved the top equation for y, substituted it into the second equation, and you got x equals -1. Then you plugged -1 back in for y, and we got 10. Okay, and number 3 and 4, again, we had to do something similar where we were going to solve for one of the equations and plug back into the other. So what we would do is solve that equation for y. So I would solve that first one for y, getting y equals negative 2x plus 5. I would then take that y value and plug it into the other part. So you had 3x minus 3 times negative 2x plus 5 equals 3. Distributing that negative 3 gave 3x. A negative times a negative gave a positive 6x. Negative 3 times 5 is negative 15. And then you got equals 3. For the next part of the problem, you had to move over and combine like terms. So you got 9x equals, adding 15 to both sides. You get 18 dividing by 9. We got x equals 2. And again, once you get your x value, you need to find your y. So you get y equals negative 2 times 2 plus 5. So a negative 2 times 2 is negative 4. Negative 4 plus 5 is positive 1. In number 4, I would solve for x, giving me 2y. Then you would take that x equals 2y and plug it in. So you had 2 times quantity 2y plus 2x equals 4. 2 times 2 is 4y plus 2y equals 4. 4y plus 2y is 6y. Equaling 4. Dividing both sides by 6. You get y equals 4 6. But that is the same as 2/3. So then you would take that value and plug it back in over here. And we got x equals 2 times 2/3, which is 4/3. So again, we should always get a value of x and y. Should always get a value of x and y. So for today, we're going to focus on something called elimination. We are going to essentially eliminate a variable in each of our problems. So over here in number 6, when you look at these two equations, we're going to add them straight up and down. So when we add them up and down, what we're going to notice is that 3x plus negative 3x is 0. So they cancel out. You have eliminated, hence the term elimination method, the x variable. You have eliminated the x variable. Then you add y and negative 2y. And then you add negative 9 and 12. So that gives me negative y equals positive 3. And you can't have a negative on our variable. So we divide both sides by negative 1. And I get y equals 3. Or, sorry, negative 3 rather. Y equals negative 3. But just like the substitution method, getting just a single variable is not enough. We have to now go back and plug this variable in to either the first equation or the second equation and solve for y. So I need to take that negative 3 and plug it back in to either the first or the second equation and solve for y. So I plugged into the first equation. So I got 3x minus 3 equals negative 9. Now I'm going to simplify by combining like terms and solve for y, or rather solve for x using the y I found. So you get 3x equals negative 6, or x equals a negative 2. So I get x equals negative 2. Again, when we are doing these problems, it is really helpful to first solve for the variable that is easiest to be eliminated and then plug back in. So let's go ahead, let's go look at example number 2. So again, I have 3x minus 2y equals 14, and I have 2x plus 2y equals 6. So if I add these two equations together, what I'll notice is that my y terms are going to cancel out with each other, giving me 5x equals 20. Divide both sides by 5, and I get x equals 4. You take your head down, Golden. Taking that 4 and plugging it back in, I solve for y. So you combine like terms, group them together, and we get y equals a negative 1. You could always take your answers and plug them back into the original to check to see if what you get actually works. So you could always take your answers, plugging them back into the original to make sure it works. So looking over at the next example, what variable do you predict we will eliminate, x or y? Looking over at the next example, what variable is most likely to be eliminated? Okay, so I heard someone say x. I totally agree. The reason we're going to eliminate the x's is because they both have a 4. So we're going to eliminate x's because they both have a 4. Now, the problem with this one is what happens if I add these two equations together? Are my x values going to eliminate? No. So instead of adding these two equations together, what do I have to do? What's the opposite of adding? Subtract. So instead of adding them together, I'm going to subtract the bottom equation from the top. So I'm going to subtract. So 4x minus 4x cancels out. 9y minus 6y becomes 3y, and 1 minus a minus becomes a positive, so you get 3. So I get 3y equals 3. You get 3y equals 3. So everybody see why it becomes 3y and a positive 3.
Yeah, you can't.
So I'm subtracting everything, right?
Yeah.
So in the past two examples, we added. So you would have added 9 and 6 previously.
Yeah.
But because instead of adding, I'm subtracting, that's kind of like saying all of these are opposite of what they were. So it's minus 4,
Figure out we can't look negative.
negative 6, and 2 negatives become a positive 2. Dividing both sides by 3, I get y equals 1. What am I going to do with that 1? How do I get x? What do I do with 1? I plug it into the original, put your head down, and solve for x. Okay guys, we got a lot more examples to go. So, next example, which variable am I going to eliminate? Because they do eventually get a little trickier. So what happens in my example here? What happens in the example here is that the variables don't cancel each other anymore, right? The variables no longer cancel each other. So what you have to do, give me a second, I'm moving the screen, I know it's off. What you have to do is multiply both examples so they do cancel each other. We have to multiply both equations so they do cancel each other. So take a minute, distribute the 5 and the negative 4 and rewrite both equations. Take a minute and distribute the 5 and the negative 4 and rewrite both equations for me now. And I picked 5 and negative 4 so I could cancel the ends. Yes. Okay. So when you distribute both of those in, you get 10m plus 20n minus 20. Negative 12m minus 20n equals 12. So combining like terms gives you negative 2m equals negative 8. Dividing by negative 2 gives m equal 4. You take that 4, and this is what Colton asked, and where do I plug this in? Well, technically you could plug it into the top equation, to the bottom equation. Technically you could plug it into the multiplied forms as well, but I always suggest plugging back into originals because you never know if you made a mistake on a multiplied form. So I would always plug my 4 back into an original. And we solve for n, and we get negative 3. Okay, look at example number 10 and decide, do you want to simplify the variable for x or for y? Multiply the top equation by 5 So you're going to multiply the top equation by 5. And then I'm going to multiply the bottom equation. And since I want the x's to eliminate, I need them to be opposite terms. So I'm going to multiply by -3. Now I can add my two equations together. Divide by 29. And I get y equals 3. We have to take that 3 and plug it back in. So you get 3x plus 7 times 3 equals 15. So 3x plus 21 equals 15. Subtract 21 from both sides. And we get -6. Divide by 3. And I get x equals -2. Okay, and number 11, I'm going to try to cancel the x's because this time it looks like I can simply multiply the top equation by 2 to match the bottom equation. So 2 times -3 is -6x. 2 times 5 is 10. And 2 times 6 is 12. Adding them together, 6 minus 6 is 0. So I'm super happy I got rid of the x's. But -10 plus 10 is also 0. Zero plus 12 is 12. Does 0 equal 12? No. So what do you think happens if you get something that's not true? 0 does not equal 12. So what does that tell you about these equations? Can't do them. So what's the math way of saying you can't do something? Nick? No solution. All right, guys, do you want to eliminate x or y? Okay, so let's multiply by 2. Six minus 6 is 0. -10 plus 10 is 0. -12 plus 12 is 0. Does 0 plus 0 equal 0? So now I have 0 equals 0. So if you get 0 equals 0, well, that's always true. So if something is always true in math, we like to use math terms. So we're going to say that this has infinitely many solutions. So what that means is since 0 will always equal 0, any combination of x and y I pick for the first equation will work for the second equation. So any combination of x or y will work. So if you get 0 equals 0, it's infinitely many solutions. In 13, we have negative 3x and positive 6. So we'll multiply by 2. And again, I get 0 equals 0. So it's the same infinitely many solutions. I have 2 and 3 and 4 and 6. So for this combination, the only way to solve is to multiply both. So let's eliminate x. We'll multiply the top one by 3. And then we'll multiply the bottom one by negative 2. So I get a positive 6. And once again, I get a case of 0 equals a number. 0 is never equal to a number. So we have no solution. Your homework for tonight is that 3-2 Solving Systems Day 2. You're doing problems on page 147. The numbers at the top, I apologize, don't match the numbers on the page. So you're doing the numbers on the page, not the numbers at the top. But it is going to be 28 to 40 if you want your numbers at the top to match. I just forgot to change it when I copied and pasted the page number from the previous assignment.